Okay, so today we will discuss about the nodal analysis. So, so basically, what is node? A node is a junction that is meeting point of entering and leaving current. If the current is here and it is divided here, then we will say that this is node 1. Okay, so basically the node, it also divides the current. Say here the current flow is I1 and here the current flow is I2. So here I will equal to I1 plus I2. So now if we have a circuit and it will be having some resistance and some voltage, how to solve that circuit, and by solving the circuit I mean how to get the voltage at nodes. So at no in at a nodal analysis, we have to calculate voltage at nodes. That's what nodal analysis is all about. So we'll start with the circuit, that is, here we have a battery source, and here also we have a battery source. This is minus positive, and this battery source, that is voltage source, we will say it's E1 and this is E2. Let's keep the resistance R1, R2, R3, R4. So before we start, we have to select the reference points. Okay, so here first we will see what is the reference point. The reference points should, let's say it is in between the, wait, it's in between the two nodes, that is we will keep this node 1 at voltage V1 and this node 2 with the voltage V2. So this we will select as a reference point, that is in between node 1 and node 2, and we will ground it, that is voltage here is 0. Now first we will calculate suppose say here the current is I, then it will get divided near the node 1, and same current, the resultant current, will flow through node 2 and that current will also be divided. So say at node 1 we have to apply KCL, that's Kirchhoff's current law, and Ohm's law. So how will we apply it? Say at node 1 we have current entering I. Okay, so that current will be equivalent to the voltage difference, the potential difference, that is E1 and V1, and divided by the resistance, that is R1. So at node 1 the voltage through the current I will be equivalent to V1 minus E1 divided by R1 plus the voltage, that is V1, and the current flowing through the R2, that will be again their sum, because the Kirchhoff's current law says all the sum of the net result of the current is 0 at the node. So here we have V1 divided by R2. Okay, V1 minus 0, that is ground voltage. So again we have another current that is flowing through this direction here through the resistance R3. We have V1 minus V2 divided by R. Say let's this R3. We forgot to mention this resistance. Let's keep it R5. So its sum will be 0. Let's keep it equation 1. The resistance will be given in any problem. The resistance will be given and this voltage will also be given. So only we have to calculate here is V1 or V2, whatever. First we will keep this equation 1 at node 1. Now moving to the node 2, we have incoming current, that is this, okay, and the outgoing two currents, that is this one and this one. So at node 2 we have voltage V2, which is the incoming current, voltage V2 minus voltage V1, because the potential difference will be V2 minus V1 divided by resistance, that is R3, this one. And again we will apply Kirchhoff's current law. So the voltage through resistance R5 will be V2 minus 0 divided by R5, and the voltage through R4 resistance will be V2 minus E2 divided by R4 equal to 0. We'll keep this equation second. Now we will solve the equation 1 and 2, and given that the resistance and the E1 and E2 will be given, we will get the value of V1 and V2, that is the voltage at N1 and N2 node. Okay.